So Assalamualaikum warahmatullahi wabarakatuh and a very good day. So today we will continue our discussions on subject BDA 14303, and we will focusing on superposition technique in order to do the circuit analysis. So at the end of this lecture, students should be able to first understand the concept of superposition theorem in circuit theory, then explain the step required in implementing superposition theorem, and finally apply superposition theorem in analyzing electrical network circuit. Let's take a look at superposition principle in physics and mathematics point of view. So the superposition principles, also known as superposition property, states that for all linear systems, the net response caused by two or more stimuli is the sum of responses that will have been caused by each stimulus individually. So, in the simple terms, we can say that if input A produces response X and input B produce response Y, then input A plus B will produce response X plus Y. So a function fx that satisfies the superposition principle is called a linear function. Superposition can be defined by two simpler properties, which is additivity and homogeneity. In additivity, we can say this f of x1 plus x2 is equal to fx1 plus fx2. While the properties of homogeneity, f A times x1 is equal A times fx1. So, electrical element that we have learned so far is also a linear element, which means we can apply the superposition theorems in doing the analysis for circuits. We know from the Ohm's law, when I1 is given into the R, then it will give the output of V1, and I2 also linearly, when I2 is implemented to a certain R value, it will give the output of V2. Then we can say that I1 plus I2 will give the output of V1 plus V2. Thus, we can use the superposition principles required that the total effect of several causes of independent sources acting simultaneously is equal to the sum of the effect of the individual causes acting at one time. The next question is why and where we should implement this superposition theorem in circuit analysis. So when an electrical circuit is getting complex to analyze and consists of several independent sources, this is where we should be able to use superposition theorems to analyze it. Here, in this circuit, we have four independent sources in E1, E2, E4, and I1. So we can use superposition theorem to analyze this circuit. This is considered as alternative method to mesh and nodal analysis in circuit analysis. So the principle of superposition is only applicable for circuit consisting of linear elements and independent sources. In order to implement superposition theorems in circuit analysis, there are 5 steps involved. So the first, we need to activate only one independent source at one time and deactivate the rest of the independent sources. So if there is dependent source is available, it should remain active. So in this example, we have 4 independent sources. So we need to determine and calculate each of these independent sources while neglecting the rest of it. So what you need to do is how to deactivating the independent sources. It really depends on the type of independent sources available. If it's a current source, like the I1 here, then you need to do is to replace it with the open circuit situations. So if it's a voltage source, as for E2 and E4 here, then we can change it into a short circuit situation. So as you can see here, the evaluation of the voltage due to E1 and due to E1, now we can determine easily. This is because in this situation, the current source has cut off the I2, so the I2 part is right now will become 0. So only the E1 will only flow through this loop of I1 and I3. So right now we calculate whatever it is required based on the analysis, and then we repeat step 1 to 3 for E2, for E4, and I1. So until all the effect of the independent sources in the network has been analyzed, then, so in this situation, for example, for E2, so the circuitry has now become E2, and the rest circuit is open, short circuit and open circuit. So same goes here. The path B, C, D, E is not activated at all because the current I1 has been deactivated by open circuit. So you only calculate the path of A, B, E, and F. For the case of E4, here, again, E4 will not contribute anything to the circuit because, again, the current source, the C and D path has been open circuit, and thus there is no contribution able to produce by E4 to the rest of the circuit because the incompleteness of the path. And finally, when we're dealing with the I1 here, then the rest of the voltage source will be short circuit, and you can see here the I1 will contribute, will be required to calculate fully based on the circuit. Finally, we need to add the total current or voltages due to all these independent sources, and from later then we can get the actual effect of current or voltage across any of the resistors due to all independent sources of the circuits.